Hello children, good morning. Today we are going to see the topic sex determination. Right, before that I just want to give you some introductions to you. Right, if you take any cell, right, the cell is always in a diploid nature. What do you mean by diploid? Diploid means it has two sets of chromosome. Right. How they got this 2n? They got n from mother, n from father, and this is the offspring having 2n number. And here we have to note these are gametes. These are gametes. The gametes are haploid in nature. And they are a normal cell is a diploid, but the gametes are haploid. Any animal for that, this is the condition, right? Okay, so I'll give you with an example. Say for example, we'll take human. There are 46 chromosomes. Okay, out of the 46 chromosomes, how we got these 46 chromosomes? 23 from father, 23 from mother. This is the condition. Suppose we will take this 23, right? Out of this 46 chromosome, we can divide this into again two types. 44 chromosomes and here one pair of chromosome, that is 45th, 46th chromosome, right? We will decide this. These 44 chromosomes are responsible for the body structure. They are called autosomes. These two chromosomes decide the sex. They are called allosomes. So autosomes, allosomes. Now we will see what is the allosome present in human, which is determining the sex. There are two types. One is X and another one is Y. Now you see 44, 45, 46. 46 chromosomes. Clear? Now this is just an introduction about what is diploid, what is autosome, what is allosome. And this allosome only going to decide the sex of an individual. Now we are going to see that. Right. Before that, the scientist Henking, he was studying about the cell division. He was doing research on cell division, especially spermatogenesis. When he was undergoing this studies, he found out certain thing. He don't know what is that. He don't know. So if you don't know, you keep X. Okay, some X factor is pausing during cell division, and he found that X factor 50% the sperms are with that X factor, 50% of the sperms without X factors. With these factors, and he don't know later the people, they said this is nothing but X chromosome. Is an X chromosome. This is how they have first found out X chromosome. Okay, now we know X chromosome. We will be going and how the sex is determined. Right, we will take human first. In this, I will take human. In human, the sex is determined where the male is heterozygous. The females are homozygous. This is the condition. What is this hetero? Hetero means different. Hetero means different. Homo means same. That means, if you see the chromosomal condition, we are now talking about sex chromosomes only. If you take the male and female here, homo, that means they have one X chromosome, then it is in a pair. Sorry, this is female. XX. So what is the nature now? They are same, both are same. So it's called homozygous. But whereas in male, one is like this, and one chromosome is not like this, which is little smaller and have a curve. So when you draw like this, I can draw like this. The Y chromosome is like this. Okay. So here, if you see two chromosomes, they are, each one is different. This is X, this is Y. But here, this is X, this is X. So this is the nature of chromosomes in human, right? When how the sex is determined, suppose if this is the condition, what will be the gamete? One gamete will be having Y, and another gamete will be having X. Here, both the gametes are having same type. Now you see, when this join with this, and this join with this join with this, and this join with this, what is that? This is X, X. This is X, and this is also X. And this is Y, and this is X. So X, Y. This is Y, X. So 50% female, 50% male. Now you see in this, which is determining the sex. The sex is determined by the male chromosome. So this is called male heterozygous condition, where the male chromosome determines the sex in human. And if you see Drosophila, the same heterozygous, but what happens is the male is having only X chromosomes. The female having X and X. Instead of that Y factor, here Y is absent, so we are mentioning 0, X0 type. And this is XY type. This is called X0 type. Here, the sex is determined based on the absence of the Y chromosomes. But that is also male heterogamous. These are the two examples for the male heterogamous. If you make the cross will be like this. Wherever there is no Y chromosome, that will become a male. But male is a homozygous nature because absence of a chromosome. And if we go to the third one, suppose in birds, in some birds, the male is homozygous condition and the female is heterozygous. It is opposite to human being. When you make the cross, how it will be? Suppose we make the male, and we make the female. The gametes are like this, and the cross is made. How it will be? And this here, male is a homozygous condition, female is a heterozygous condition. So here the sex is determined by the heterozygous nature. That is why it is called female heterogamy. This is male heterozygous and female heterozygous. Male and female heterozygous. So this is the example. So this is how the sex is determined, and all these are allosomes, not autosomes. Okay, the sex is determined by the one pair of chromosome. They are called sex chromosomes or allosomes. Now, in bees, because it is in the book, in the bees, how the sex is determined. The sex is determined in the bees, say male and female. Female is with a diploid condition. They have 32 chromosomes, but male is with 16 chromosomes. Then how it will produce gamete? And this will produce a gamete by mitosis. So it will produce gametes. All gametes are with 16 by mitosis, but they will produce gametes by meiosis. So the gametes are like this. When this one and this one is formed, it will become 32, and this is alone. Okay, and this will become female, and this will become male. Okay, now you see, they used to say they don't have father. They don't have father. This male doesn't have a father, but they have grandfather and grandsons. They don't have father and they don't have son, but they have father and grandfather. The reason is, suppose you see this female is having half of the chromosome from here, half from here. When they undergo reproduction, when the gametes are formed, from here one gamete goes and meet the other gamete and form a female. So this we got it from, at least from the grandfather. Okay, that is why the bees, it's a different type of sex determination, and the male is formed by parthenogenesis. Even without fertilization, they become males. They have only half the number of chromosomes, they haploid, and they become males. This is a new type of sex determination which is in bees. Okay, so go through this, children, and you have doubt, you call me or send your doubts, I will clear. Okay, bye.